Okay, so let's try one more here. Okay, the square root one. Okay, well, let's set this up. Okay, so again, let's draw our picture here. We've got square root of x. Okay, so we're going to have square root of x. And at x equals 3, let's say x equals 3 is right about there. Okay, y equals square root 3. Okay, and I'm going to choose some arbitrary point a little bit further away. We're going to say that that is 3 plus h. Okay, so that coordinate there is going to be square root of 3 plus h. Okay, and then I want to know the slope between those 2 points. Okay, so I'm going to do my limit. So limit. I'm going to let the h go to 0 again. Okay, those 2 points are going to come closer together. And I want the rise, okay, which is y1 minus y2 all over h. Okay, so when I let h is 0, I get root 3 minus root 3 is 0 over 0. Okay, my problem. How do I get rid of that root h, that h in the bottom? I need to somehow free up that h inside the square root. Now, this is something it's hard to kind of think of, but once you've seen it, you should remember this and know this. Okay, so we're going to get rid of that. We're going to unwrap that h in the square root by doing this. We're going to multiply by a conjugate, okay? Because if we can't just square the top and bottom, we change the fraction. But if we multiply by square root 3 plus h plus root 3, okay, that's a conjugate, and that's going to give us squared minus square, which is going to get rid of that square root. And if as long as I do the bottom the same, I don't change the fraction. I don't change my slope ratio. Okay, now it does give me the square root h in the denominator, but this root h is not the problem. It's this divide by h is what the problem is. Okay, and that's the one we want to get rid of. So let's see what happens here. Okay, so when I do that, I end up with the limit as h approaches 0. This is going to end up being 3 plus h square root squared. Okay, so it's going to free up that 3 plus h minus root 3 squared is going to be 3. And that's going to be all over my factor h times this big mess here. Okay, so 3 plus h plus square root 3. Okay, well, these 3's cancel out. I'm just left with an h in the numerator. Well, that's great. That's exactly what I wanted. That's a factor of h, which will cancel with the denominator h. Okay, so this is going to look like this. Limit as h goes to 0. Maybe I'll do a couple steps here. So the 3's cancel out. Okay, the h's cancel out in this step. Okay, so we're left with just 1 in the numerator. So limit as h approaches 0. Okay, and this is going to end up being 1 divided by square root 3 plus h plus square root 3. Okay, so if I let h be 0, that's not a problem because it's going to give me square root 3 plus square root 3. Well, I can evaluate that. That's going to be 1 divided by 2 square root 3's in the denominator. It's just going to be 2 root 3. So there's my slope. Okay, so the tangent line slope at that point of x equals 3, that slope we're claiming is 1 over 2 root 3, and that's true. Okay, so we can actually graph a couple of these, and we can see that these tangent lines Okay, these slopes that we calculated are in fact the slopes of those tangent lines.